Welcome, 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 everybody. Before I get started, I'm just gonna let this go for just a little bit. Make sure we got everybody who signed up who wants to be here live. Until then, how's everybody doing? Oh, also, in case you missed it, on the registration page, we have support in Discord under the Offensive Ops Discord, SANS Workshop. Hopefully you all are there. All right, so who's in Discord? Give me a shout out. TPZ, you out there? Here? Yeah, thanks, Randall. I'm glad you're there too. All right, who was here for part one? Did anybody catch part one? So I'll basically start off kind of where we left off with part one. Got it on demand. Hey, cool. Good enough. All right, well, looks like we're up to 35 folks-ish. Nope, some more popping in. Okay, just give it maybe just one more minute, and we'll go ahead and kick things off here with part two. Looking through the people who signed up so far, looking for some familiar names. Alan, good to see you, Alan. Hey, awesome. Let's see who else is there. Julie, good to see you, Julie. TPZ, yeah, awesome. Sweet. All right, looks like we're doing pretty good with participants here. So with that being said, let's go ahead and officially kick off part two. Cool. Where we left off from part one. Okay, so for those who didn't see part one, either live or on demand, here's what's going on. At this point in time, we have Visual Studio 2019 or 2022, the Community Edition installed. And part one, basically, we're talking about integers, Windows data types, C data types, introduction to the main function part of your program. And we played around with some bit shifting and a few of the items, just having fun here and there. And then part two, is basically going to continue where part one left off. Okay, I didn't get to go over everything that I wanted to for part one. So the first few minutes here, we'll talk about some of the some of the extra things I wish I could have put into part one, but just limited by that 2-hour time constraint there. Okay, so excuse me, give me just a second. Oh, also, for those that are joining for the first time ever, how I'm doing this, the format for this workshop is I want you to follow along with me. Okay, so what I have open right now is just a basic solution that I called Intro, and I created a new project for that solution, and it's called Part 2. All right, couldn't think of a better name for it, just so Part 2 it is. And if you could, go ahead and type out the skeleton code right here, or this boilerplate. Bring in a couple of header files, and then our skeleton for our main function. Okay, sweetness. For the workshop, I'm not going to have any dedicated lab time. So whenever I type something out, when I'm typing through, creating some program, throwing up some code in here, I want you to follow along with me. This is a gigantic group exercise, if you will. And then we'll debug our code together. We'll run the code from other terminals together. And we'll have probably some growing pains, maybe some debug errors, or build errors or what have you. And we'll fight our way through it as we flip over to a troubleshooting mode. And we try to figure out what in the world is wrong with the code. Okay, so it's kind of nice also to have Discord. So if you have any questions, feel free, pop them in a Discord channel under Sans Workshop and fire them off there. And I will try to monitor that channel as best as possible. Right. So if I'm not answering your question straight away or in a timely fashion, I apologize in advance. Just want to maybe get some thoughts out there or get some code out there while I'm thinking about it. And then I'll pop over to Discord and see what I've missed, if anything. And then towards the end of this workshop in just under 2 hours, I'm going to pause a little bit earlier to give some time for a Q&A session, and maybe a little bit of what to expect for part 3. Sweet. Okay, so assuming that you all already have the skeleton code out here, let's go ahead and press on. Here's what I want you to do next. Okay, so inside of our main function, I would like for you to create 2 variables. Okay, so the first variable is going to be of type int. Right, we talked about integer types in part 1. There's a C runtime version of it, and then we are going to use the Windows data type, okay, of int. Okay, so this int is just going to be named min. You can name it whatever you would like to, but for me, I'm just going to name it min. And I'm going to set this to the value of -1. Okay, so integers, remember, from part 1, they are a signed data type, so they can have a signed bit that will indicate if that value is to be treated as a negative number or a positive number. So once you have that one, go ahead and jump on down on the next line, and I want you to create an unsigned int. So this one's just me, uint, okay, in all caps. And for this one, I'm just going to call this max. Okay, and then there's a very large number that I want you to put in here. Okay, so here we go. Let me break this out into 3s, make it a little bit easier for y'all to read. Okay, so 429, 496, 729, 5. Okay, so that's just for readability. Obviously, we can't store a value like that. Okay, so that magical value right there is the largest value that you can shove into an unsigned int. Okay, so that's the max. That's the max that you can do there. I mentioned in part 1 that there can be some undefined behavior, some shenanigans that can happen when you start to mix and match different data types, especially signed versus unsigned. So here's one such example of what I mean by that. Okay, so what I want you to do is I want you to make a printf statement here. Inside of printf, I want you to basically, we're going to make whatever status message you want, or you can copy mine exactly. But what we're going to be doing is we're going to be doing some comparisons between these 2 values. Okay, so the first check is I'm going to say, is the min value equal to the max value? Okay, so that's my little message right there. And you might be looking at it right now and saying there's no way. There's no way on this earth that those 2 values would ever equal each other. Okay? So I'm going to add in the %s because a string is coming. All right, so with this formatted string, we're going to go ahead and give it something. So I'm going to teach you something new here, a ternary operator. So let me space that out, make it a little bit more readable. Inside of these parentheses, okay, so I got a comma and then a set of parentheses. We're going to be doing our comparison here. So we'll go ahead and we compare to see if min is equal to max. Okay, so just min, a double equal sign, and then max. And then for this operator to work, this terminator operator to work, I do the question mark. Okay, so question mark, and then a string, and then a colon, and then a string. This is the format for these operators. Okay, so the reason why I'm using strings is because I have the %s inside of the format string, so that's what's going to be going there. And so we say, hey, if the result of this condition or this check is true, then we'll just say yes. Okay, so yes, min is equal to max. Otherwise, that's false. And so we're just going to say no. Okay, so I'll give you all a little bit to make sure everybody's on the same page. I'm just going to save it. Okay, and then I'm going to hit Control B to go ahead and build it. And looking at the output window for any kind of errors, and looks like we have success. Okay, perfect. Now what I'd like for you to do is open up a command prompt window. Okay, it could be, it doesn't have to be elevated or whatever, just a command prompt window, and navigate to wherever that compiled binary is stored. Okay, obviously my folder path is not going to be your folder path, so don't try to navigate to this folder because it's not going to be on your side. All right. And once you're there, go ahead and execute it. Okay, it says is min equal to max? It says yes, it is. It absolutely is. You're like, what? No way. Those are lies, right? Something's wrong. You got crap code. What's going on here? Okay. Well, this is some of the shenanigans that happens when you do mixing and matching with different data types, especially signed versus unsigned. For behind the scenes, for these comparison operators and stuff that's happening here, the integer value is being converted to an unsigned value to go ahead and compare that with another unsigned value. So when you go ahead and you take a negative value and you flip that to unsigned, it becomes a very, very, very large value. And the value that it becomes is this one right here, which is why the comparison here of is min equal to max resulted in true. Okay, so that's why yes was substituted here instead of no. Okay, kind of crazy stuff, right? So when you're going through, especially in the world of implant development, you definitely, absolutely have to keep this kind of stuff in mind. Okay, so there are many functions out there that obviously return different data types. And for numbers, integers, you need to pay attention to the sign of them, how they're going to be used, what you're going to do with it. Okay, are you going to be adding unsigned numbers to signed numbers? Are you going to be subtracting them? Are you doing any bit shifting operations? And also stuff like this, are you trying to compare unsigned numbers with signed numbers? Okay, so one more example of something I want you to do to show you another crazy thing that happens when you mess around with signed versus unsigned. Okay, so I'm making another printf statement here. And what I want to do here is I'm going to be checking if max is greater than min. Okay, so is a positive number greater than a negative number? Okay, so I'm going to say is max greater than min? And I'll do %s, okay, to make this a formatted string. I'm going to do my fancy little ternary operator here and say max greater than min, and we'll do the question mark and the double quotes, the colon, and the double quotes. Okay, the standard format for this operator. And we'll just say yes, if I can spell correctly, and then no. Okay, so if max is greater than min, we'll say yes, it is. If not, we'll go ahead and say no. Okay, so I save that one and Control B to go ahead and build that out. And I flip over here to my command prompt and I run part 2. That says no. Nope, it's not. It's like, what? Come on now. All right, so again, this is all about that negative value, that signed integer, being converted over to an unsigned integer. Okay, some of the shenanigans that's happening behind the scenes can really mess up your program or your code. Okay, so again, I can't emphasize this enough. Knowing some of the behavior of what can happen when you play around with some of these different data types. Okay, so in the world of vulnerability classes, there's like integer overflows, integer underflows, so on and so forth. I kind of talked a little bit about that in part 1, so I'm not going to deep dive into that here for part 2, but this is basically a continuation of that, seeing what happens when you flip a negative value, a signed integer value, to unsigned. Okay, some crazy stuff. Sweet. All right, let's go ahead and move on, shall we? So part 1, I kind of gave an introduction into bit shifting. We talked about truth tables, ANDing, XORing, ORing, that kind of stuff. So let's take that a step further. In Windows programming, there can be times when it is very useful to see if a certain flag is set or if it's cleared. So what we're going to do is we're going to make a macro. Okay, so a macro, in my world, I create my macros in header files, but just to save complexity and keep things simple here, we'll create our macro here right above our main function. Okay, so right after the header files, I'm making a pound define. Okay, so I'm going to define a little macro here. And what this macro is going to do is it's going to test to see if a certain flag or a certain bit position is set, meaning it has a value of 1, or if it's clear, meaning it has a value of 0. So let's call this flag on. Okay, so flag on is going to take 2 arguments or 2 functions. The first one is going to be flags. Okay, so this is going to be the actual value that is coming into the macro. And then the next piece is going to be the flag of interest. Okay, so the bit position that we want to test against. Okay, so those are the arguments. So let's go ahead and build out the actual logic. Okay, I'm just going to space that out for readability. Okay, so here we are inside of the actual implementation for the macro. All right, let me make sure I'm not missing anything in Discord. Cool, all right, everything's looking good. So for the implementation, we're going to use a bitwise AND operator. So I'm going to say, I'm going to put some placeholders out there and then my AND operator. Okay, so let me move the mouse out of the way here. So over here, on the left-hand side of the operator, we'll say the flag's value, right? So the actual value that is coming through this macro, we'll do the flags, and we're going to AND the flag of interest. Okay, so that is the flag on macro. How in the world could we use this? Okay, how do we test for this? How do we determine if a flag is on or if a flag is off? Okay, so what I want you to do here, You can keep everything here if you would like, or you can go ahead and get rid of it. It doesn't matter. It's up to you. I'm just going to say the next class, I'm going to make another unsigned int, another uint variable called next class. I'm going to call it 770. Hopes and dreams, right? Hopes and dreams. So this next class, let's say it has, we got that value of 770, and I'm interested to see, if there's a certain flag that is set inside of this value. Okay. To do that, you could say, hey, maybe I want to know if this value is a multiple of 16 or it's divisible by 2 or some multiple or whatever. Okay. So what you could do is you can go ahead and make a printf statement. All right, so yeah, we're going to be using a lot of printf statements, right? Obviously, in your implant code and stuff like that, you're not going to be printing anything out to the terminal window. That's definitely not going to be a thing. All right, so in any case, what this printf statement is going to do is we're going to ask a question. We'll display a question to the screen and say, is 770 a multiple of 16? All right, we'll do a %s. Okay, and then we'll go ahead and we're going to do our operator again, our ternary operator, and we're going to use our flag. So flag on, question mark, quotes, colon, quotes. All right, so that's just how I get things prepped. I get the format down, and then flag on. So the flags we're passing in here is going to be next class. And then the flag of interest, to see if it is a multiple of 16, okay, I'm going to give it hex 10. You could give it decimal 16, whatever, it doesn't matter. And I'll say yes. If that's true, then it is a multiple of 16. Okay, if it's not, we just say no. Okay, you could also say false, you could also say true or false if you would like. Okay, so again, to recap what's going on here, this flag on macro, we give it the flag's value. Okay, so the value of 770 for this case, and we're testing that against hex 10 or decimal 16. So I'm going to save that, build it, and when I see that's done, build one success, okay, and run it. Is 770 a multiple of 16? No, it is not. Okay, so you can go ahead and test that with a calculator and verify if you'd like. Okay, only thing that's happening behind the scenes is figuring out what the binary value is of 770 and going through looking at bit position 16 to see if that is set or not. Okay. Now, I don't like these things that I call magic values. This right here is a magic value, right? Unless, I mean, maybe, so for example, here's why I don't like magic values. Let's say I'm coming back to my code 3 years later, or sometimes my terrible memory is 3 months later, or 3 weeks later. I have no idea what hex 10 was all about. Okay, what in the world? What's up with this? So I want to convert this into something that is a little bit more readable. So if anybody's coming along after me, trying to understand my code or anything like that, make this a little bit better. So what you can do is create a constant up here using pound define. And we say, is this a multiple of 16? And just OX10, okay? So what I can do now is I'll take this constant and paste that in here. So to me, that is a lot more readable. It makes sense. If I look at this code 3 years later, I know exactly what's happening here. All right, so this is just me. This is what I love to do. Y'all can take this, run with it, and bring this into your place as well. but this is what I love to do. Cool. So let's add another one. Okay, let's add another constant here. So define, and let's do. Let's test for odd. So is it an odd number? Okay, and then we'll say the value of 1. And we'll add another printf statement here. And we're going to be modify this just a little bit to say is 770 an odd number? And then %s. Undo our little operator here. Test for flag on. Question mark, quote, colon. And there we go. Let's pass in our flags value. Next class. And then flag we're looking for here is odd number. Yes. No. Okay, I'm going to go ahead and save that one. Build it. All right, build was successful, sweet. And it says 770 is definitely not an odd number. Okay, cool. Well, let's go ahead and change things up a little bit. Let's go ahead and add another macro to go ahead and set a flag. Okay, so now we've seen what we can do to test for certain flags. Now let's go ahead and set some. So come up to your flag on, and right below flag on, I want you to go ahead and create a macro called set flag. Okay, and just putting the placeholders in here. And set flag is going to take pretty much the same kind of parameters as before. We have our flag's value, and then you can name this whatever we want, but this is the flag that's coming through. Say the flag that we want to set. Okay, I'm just going to say flag. Now the implementation piece. So putting my parentheses here, what we're going to be using to set a flag is the bitwise OR operator, but the equal sign. Okay, so in part 1, we talked about some arithmetic operators, how you can do addition and assigning that addition value back to the variable all at the same time, doing like plus equals, minus equals, so on and so forth. And the same thing can apply here for bitwise operators. Okay, so or equals. Inside or on the left-hand side of this operator, this is our flags. And then on the right-hand side, this is the flag. Okay, so the flag that we want to set, we'll go ahead and do the OR equals operator, storing that value back into flags. Okay, so whatever comes through. Now, once you have that implemented, we'll go ahead and skip a few lines, and we're going to call the macro. So we'll say set flag, next class, and let's go ahead and set the flag odd number. Okay, so to see this happen, we'll go ahead and do another printf statement. And we'll say, so the value this should become, it should become 771. So we'll say is 771 an odd number? And then we'll come back here and we'll go ahead and do our flag on ternary operator. So flag on. So is the flag on? And whoops, I need a question mark. And so just getting through the motions here. Next class. And we're testing for the odd number flag. And if that's true, we'll say yes, it is odd. Otherwise, we'll say no. Okay. So I'll save this and build it. Now, this time though, instead of going to our terminal window, I want you to do some Visual Studio debugging here. And what I would like for you to do is set a breakpoint on the set flag macro. Okay, for me, it's line 24. All right, so we're gonna break right there. And it doesn't matter, it doesn't really matter if you're gonna build out debug or release or what have you, but if you would like to go ahead and match mine exactly to match my output, go ahead and choose debug and for 64 bits. Okay, so debug x64, and then I'm gonna choose a local Windows debugger. Go ahead and click on that one. All right, does this print things, print messages happened, and we have our breakpoint right here at set flag. Okay, so if you look at next class, you can see that it has a hex value of 302, okay, because set flag hasn't happened yet. So go ahead and step over the macro here. So step over that one, and inside of your locals window, you should see next class, the value of next class changed to red, meaning, hey, something changed here. Can I get your attention, please? And now we see the value of 303. Huh, how about that? So we see that obviously the set flag macro came in and went ahead and did the or equal operator against 770. And now we see just incremented by 1 from hex 302 to 303. Now here we go. We'll go ahead and step over the printf statement. Okay, so there you go. And something interesting popped up. Well, it didn't really pop up like a message box, but in any case, inside your locals window, you'll see that it says printf returned. Huh, printf, yeah, it returns values. It returns the number of, I believe it's bytes that are actually printed out and sent to standard out. Right, so this one is the value hex 1B. Some random knowledge there for you. So let's see. Is 7071 an odd number? Yes, indeed it is. Okay, so cool. So we're taking it a step further. We learned so far how you can test for certain flags to be on or off. And also now we went ahead and took a look at how in the world we can set flags to be on. Okay, so back inside the debugger, you can go ahead and hit continue to let that one go all the way through. And then inside the debugger console window, you can go ahead and hit any key you would like to close it. I just hit the space bar. Right, it's easy. So where can we go from here? We talked about flag on, talked about setting flags. So let's go ahead and talk about clearing flags. So underneath your set flag macro, do another define. Clear flag. Yep. All right, so following the concept from the other ones, we got our flags and then the flag that we'd like to clear. Okay. Now this one's gonna be a little crazy first time seeing this through. So setting my placeholders, if you will, inside parentheses where the flags is going to go. On the right-hand side of our operator coming up is the flag that we want to clear. So the operator that we're going to be using here is an and equals. Okay, so and, or the ampersand, and equals, and then the tilde. Okay, so tilde. Okay, so this right here is how we can actually clear a flag. Okay, so again, the terminology using here, set and clear. So set, meaning the value of 1 is present, and clear, we're taking that away, and it's saying the value there is going to be 0. Okay, so clear flag. Now, how do we use this? Okay, so underneath this printf statement, very similar to how we called the set flag macro, go ahead and call clear flag. Okay, so clear flag, and we'll keep using the next class variable. So next class, and the flag that we'd like to clear is the odd number flag. So odd number. And what this is going to be doing is basically we get rid of that flag, we clear it, and now it's going to become an even number again. So let's go ahead and make another printf statement. Okay. So what I'm going to do this time, though, we're going to modify the printf statement just a little bit. And here's what I'm going to put inside. I'm going to put inside that right there as a string. Okay, so clear flag, next class, odd number as a string. And I'm going to say is equal, so equal sign, %i. And then inside of parentheses, we're going to show the hex value of this. So it's going to be 0x, %08x. Okay, so show me 8 hexadecimal characters. And then go ahead and use our same operator we were doing before using flag on. So flag on. Feel like I'm in a Marvel movie, flame on. Flame on. All right. Squirrel. Next class. And we're testing for odd number. All right. And filling out the rest of that. Go ahead and minimize that window just a little bit. Cool. So we already going to do that. So let's go ahead and get rid of that. We did that previously. Okay. So my bad. All right. So that's obviously not going to work for that format string that we got here. So here's what we do. So you pass in next class and go figure next class again. Okay. So what we want to see is I want to show you the integer value of next class and the hexadecimal value of next class. So save it. And this time change your breakpoint. Move your breakpoint. So clear the one on set flag. And now set a breakpoint where your clear flag is going to go. Then go ahead and run local Windows debugger. And wait and wait and wait. Cool. So here I am at my breakpoint. Set flag has happened. We have hex 303. And some of our printf statements have triggered. Cool. Everything is looking good. And clear flag. So I'm watching my locals window to see what happens. And I'm going to step over, or F10. Boom. There it goes. The flag has been cleared and is no longer hex 303. It is now hex 302. So I'll go ahead and step over the printf statement and fire that away. It says, there it is, 770 hex 302. Okay, cool. So back inside the debugger, hit continue, let it go about its thing and execute properly and return, and done. Okay. Now, how could this be applicable for Windows Dev, Implant Dev, or what have you? Okay, so Windows internally will go ahead and be checking a lot of flags to see what has been set or what kind of mask is there, so on and so forth. Okay, so I'm going to go ahead and let's see. Let me pull up a header file on MSDN real quick. I'm going to look at the page protection permission constants. Bear with me. Just to show you something as real as possible. Okay, so define the page execute. Okay, so I'm just pulling these values from MSDN. You can go ahead and type them in as I type here. Okay, so we have page execute as a value of hex 10. And you get rid of the extra 0 there. That's not a thing. Okay, so page execute read, and that is the value hex 20. And the next one is execute read write with the value of hex 40. Okay, and then I'm also going to add some memory stuff as well for pages of memory. Looking at MSDN here, so pound define mem commit as a value. How many zeros is that? Okay, so value hex 1000. And so that was mem commit. This is mem reserve. And it's just hex 2000. Cool. So what I have here, just recreating some of the constants that Windows uses internally to represent page execute permissions, page execute read permissions, and page execute read write. Okay, or you would see it in like a debugger or whatever as RWX. Something you want to avoid RWX all at one time for implant dev. And then for page, when you're allocating pages of memory, you can all in one full swoop call mem reserve and mem commit to go ahead and reserve some pages of memory and commit them. Okay, cool. So now we have those. What we can go ahead and do is create a new variable here, and we're going to make this one specific to memory. So ulong, an unsigned long. Okay, so ulong memory, and I'm going to say mem commit with the OR operator of mem reserve. Okay, so just ORing those two values together. Okay, so typically you'll see this commonly used in a call like this, right? You don't have to type this one out. Okay, so virtual alloc is a way to allocate some virtual memory, at least a page of memory. And sure, a page of memory is hex 1000 is your default size of a page. And the allocation type, this is where you would do the mem commit and mem reserve. I can, since I already got that one, just pass it in there as memory. It's going to be like, oh, why using dword versus ulong? Guess what? They're the same thing. Okay, and then dword, let's see, coming up here, let's just do page execute or RX. Okay, so this is typically what you'll see for API call to virtual malloc or virtual alloc. Okay, so allocate a single page of memory. We are committing, we are reserving and committing that all at one time, and the permissions I want that page of memory to have would be readable and executable. Okay, so cool. So that's where it comes into play. So virtual alloc behind the scenes could do something similar to what we're doing a flag on to say, hey, is the mem commit flag present? Is the mem reserve flag, is that present? Okay, so let's go ahead and test that out. So printf, make another printf statement here. And we're going to say, hey, is memory being committed? So is memory being committed? So question mark and %s. Do our yes, no thing here. So testing for flag on. Inside of flag on, we'll pass it memory. And the flag of interest be mem, if I can type, mem commit. Yes. No. All right, save it, build it. Okay, and then inside your terminal window, go ahead and run it. So yes, memory is being committed. Okay, so that is pretty much close to a real world example of what Windows is doing internally to test for certain values, certain flags, or whatever being set or present. Okay, so flag on or is flag present or what have you. A lot of that logic, the underlying logic is exactly the same. Okay, using those bitwise operators to test for certain bit positions to see if they are set or cleared. Okay, does anybody have any questions about that before we move on? Okay, all right, cool. Everything's looking good. Sweet, all right. What I'd like for you to do now is go ahead and get rid of everything inside of your main function. Boom, gone. You can keep the macros up top if you like. So now we're going to go ahead and move over and talk about arrays. Okay, arrays are a very interesting type of variable. Okay, so the general syntax is something like this. Okay, so let me make a comment here. The syntax looks like this. You have a data type. Okay, so I'm going to say type. So you got your data type, and then you have your variable name. And for an array, you have these brackets, these square brackets, okay? Not braces. The braces are the curly things like that. We're talking about the square brackets, okay? So that's the overall general syntax of how you can create an array. An array has all the values inside of the array have to match the type for your variable name. So, for example, let's go ahead and create an array of integers. So the type is going to be int. Okay, so int, and variable name, classes, then our brackets, and a semicolon. Okay, so that's, again, that's the general syntax for how you go ahead and you create an array. Now, inside, you have to say how many items are going to be held inside of this array. So now three of them. Okay, and that red squiggly went away. And I haven't initialized this particular variable yet, or I have not initialized this array because I want you to see something. So here we go. Let's do a printf statement. And we're going to access every single item inside of this array. Okay, so inside arrays, we have a zero-based index, meaning the very first item that would be in this array will be at index position 0, and then index position 1, and then position 2. Okay, so even though we see the value of 3 here, we're starting our index counting at 0, so it's 0, 1, 2. Okay, so think like a computer. And let's go ahead and say at index 0, and we're dealing with ints, so it'd be %i. So we got that. Index 1, %i, and of course, index number 2, %i. Now we got to come in here and actually access those specific indexes. So classes. And we got 0. And I'm just going to copy and paste the rest of this, fill it out later. There we go. And 1, 2. All right, so I'm going to save that one. And we build it. Okay, so build was successful. Go ahead and run it. Whoa, what is all that nonsense? All these very large negative values. What do you guys have? Do you guys have negative values as well, or some other kind of garbage? Let me know. Let me know in Slack. What do you guys have? You have anything that makes sense? What's up with that? Yeah, so I got my index 0 this value here, and then we see that same value again, and see it again. Yeah, same values, uninitialized. Yeah, absolutely. It's garbage. Garbage data is here on the stack. Okay, so we're not dive into stacks just yet. Okay, so later in the series, we'll talk about stacks. And what stack frames are. But this is a proof right here as to why you must always initialize your variables as soon as you can, okay, before you start to access indexes or do math operations or whatever. You try calling like heap alloc or malloc with a negative value. Right, you're gonna have some very interesting behavior there. So let's go ahead and take care of that. Let's go ahead and initialize this. Put a for loop in there. We'll get to looping a little bit later. Yeah, hang on there, TPZ. I know you're itching for the next thing. All right. So to initialize an array, okay, so this array is going to hold 3 items. So the array, the syntax for initialization, we go ahead and use the braces. And we got some classes here, 670, 770, 870. All right. Again, hopes and dreams, hopes and dreams. So save it, build it, run it. Look at that. There we go. All right, makes sense. All right, the garbage data is gone. We initialized everything properly. Okay. Now, I want you to do something else. Okay, I want you to see this in the debugger. Get rid of everything after 670. So just this. Okay, we have one item, 670, delete everything else. And I want you to set a breakpoint at your printf statement. Okay, go ahead and jump into your locals debugger, your local Windows debugger. And you wait and wait and wait. Okay, there we go. Okay, so inside of your locals window, you'll see the classes variable. Okay, if you go ahead and click that drop down, you'll be able to see each item inside of this array. Okay, it's kind of cool. So we see the value of hex 29E. Okay, so that's for 670, obviously. But then we also have value of 0 and 0. Okay, so that's kind of nice. It's better than having garbage data in here. Okay, so let's see what happens if we execute this printf statement. So we'll step over that, come over to the debugger console window, and it says index 0 is 670. Okay, cool. That's what we told it to do. And then it also was very kind and initialized the remaining items to 0 instead of having garbage items in there. So sweet. Thank you for doing that for us. Okay, so come back in here, just hit continue, let that go. And I'll go ahead and close that window. Here for the use after free exploits. Yeah. Wouldn't that be nice? Okay, so in a nutshell, that's how you can create an array of integers. Okay, now again, I have to tell you, I don't like using these magic numbers. Okay, so what I would do to further enhance this is I would create a new constant. Okay, so you could just say array size 3. So pound define array size 3. I'm gonna bring that in here. Swap that out. Everything is still the same on the back end. If you go ahead and debug this again, it's going to be the same thing. There's going to be 3 items in this. Okay, I'll go ahead and hit the debugger real quick to show you. Nothing has changed. Okay, it's all still there. Okay, perfect. Nothing new. To me, that just enhances the readability for the program, for the code. That way, if anybody's coming along after me, they can quickly know exactly what's happening here with this array. Okay, so remember that arrays are indexed based with the very first item being at index 0. Now, one of the things that you can do once you have your array established or you have your array created is you can go in and modify the values at any one of these indexes. So let's go ahead and do that. Let's go ahead and modify the classes array at index 1. And let's go ahead and call this one 660. And I'm just going to copy and paste that printf statement, put it down there, and build that. Okay, cool. And actually, what I'm going to do right here, I'm going to debug it. I want you to see what this looks like in a debugger, okay? You can run on your side, but also check it out in debugger. Okay, so step over that printf statement. Boom, bye-bye. Okay, so classes index 1 is going to change from 0 to 660. I'm going to expand that out here. And I'm going to show you the memory window. Type in classes inside the memory window. All right, just to show you a different view, something you can see inside the debugger here. And we'll step over that line. Okay, classes, boom. Hex 294, you can see that in red inside of the memory window as well. But remember your endianness here. This is little endian. So we got 2, right? We got 2 right there, and then 94. Okay, the value of 294, which is just 660. Okay, so we'll go ahead and execute that printf statement and see what it is. Yes, indeed, 670, 660, and 0. Okay, cool. See, what am I missing inside of Discord? Loops, more topics, more discussion about loops. That's coming. Yep, 4 loops are coming. Probably not this one. It's probably gonna be in part 3. Okay, so, all right, that is the basic foundation for arrays. Okay, the same can be applied for any kind of data type, integers, unsigned longs, unsigned long, whatever. Okay, so the next thing I want to show you dealing with arrays still are strings. And so let's go ahead and switch over to strings. Two are the variables to 0 instead of leaving it as garbage. I would defer that to a compilerism, and I would have to do a further deep dive to give you the most technical answer for that one, TPC. That is a good question. I do not know if all compilers do that. Any Linux fans out there, let me know. Do an experiment and see what happens. Sweet. So let's see if we can talk about strings right quick. I know we're coming up at 4:30 my time here in Northern Virginia. All right. And we'll go ahead and keep our little comment here for how it creates arrays. So we're going to go ahead and create a char array. Experimentation time. Yeah, indeed. Yeah, we'll get there. We'll get there. All right, so for this one, for this array, I'm not going to come in here and give it a value here. I'm not going to give it a value for the size of the array. I'm just going to come in and straight up go to my double quotes, and I'm going to say command.exe. Okay, so that right here is our char array. So the char array on the back end of this is just values. Okay, so integer values that represent these characters. So like C, M, D. Okay, so they have a value for that we'll see in memory. Okay, and to see that one, let me go ahead and show you, and feel free, follow along on your system. I'm going to save that one. Got my breakpoint, and I'll go ahead and do local Windows debugger. Yeah, we don't need strings header just yet. Okay, there it is. Inside of the locals window, you should see your variable there, and you can go ahead and click the drop down. Look at that. You can see every single item inside of that chart array. And furthermore, you'll see the actual underlying number or integer that represents that specific character. Okay, so C is the hexadecimal 63. We got 6D, 64, and 2E. Now to see that in your memory window, if you're in the debug build, you can go ahead and just type in the name of the variable as your address. Okay, boom, there it is. Okay, so we got 63, 6D, 64, 2E, 65, 78, 65, and then what? What's this right here? We have a null byte. I don't remember putting a null byte in here, right? That's some magic. Okay, so that's happening thanks to the compiler. It sees our chart array and it'll go ahead and automatically insert a null terminating value at the end. Okay, so great. Thank you, compiler, for doing that for us. Because let me go ahead and continue right here. Instead of me having to come in here and do something like this, okay, just to be explicit, I don't have to. The compiler sees this and says, oh, all right, this is done. We'll go ahead and insert a null byte at the end of that. Now, what's very important to understand about C style strings, okay, C++ is a different beast. For C style strings, for certain functions to operate like stir length, to find the length of a string, a loop has to take place. You have to iterate over each individual index. So loop over this, loop, 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 all the way through, all the way until you find what? It's a question for you all out there in Zoom world. What do you think it's looking for at the end? Yes, absolutely. Looking for that null byte, okay, to say, hey, this is the no kidding end of our array, okay, end of the string. So let's go ahead and bring in the strings header file. So go up to the top and include strings.h or string.h. Okay, cool. And now we'll go ahead and, since that brought forth a few commands or a few functions, let's go ahead and see what we got here. The first one is stir length. Okay, so just type in strlen and your parentheses. Okay, and then do a hover. Okay, get your mouse over stir length and do a hover. And it says it is of type size T. Okay, so if you're going to store this in a variable, you need to make sure that you match that particular type. So I'm going to go ahead and do that now. Say size T, and we'll say command length. Okay, so size T is the type, command length, and then the argument for this says constant char star and string, or just stir. Okay, so, and we'll go ahead and pass in CMD there. Okay, so save that one and build it and run it. Waiting for my build to succeed there. There we go. Haha. Okay, yep, got nothing, right? Hopefully y'all got nothing either, because I missed the printf statement. So let's go ahead and add that. And I'm going to do stir length command is, now let's show you what this looks like, okay? I'll go ahead and just say, just do a %i, okay? Do a %i. Command length, okay? And save that one, build it, and then go ahead and run it. Yeah. So stir length says 7. Okay. And furthermore, inside of your output window, it says, hey, something weird here in your code, because your format string here is a %i, meaning a signed integer, but yet we have type size t being used and being passed in. So if you hover over size t, it'll show you it's been type defed as a ulong pointer. If you want to see where that is, hit F12. F12 will show you the header file where this type has been created, and it says ulong pointer. Say, what's a ulong pointer? F12 that. And looks like right here says, if Win64 is defined, a ulong pointer is unsigned int 64. Okay, so that's not %i is not an accurate representation for 64-byte int. So we have to change that. And it gives us some suggestions. It says, hey, maybe you want to use %i64 right before it. So let's go ahead and do that. So I64. Save it, build it, and then run it. Wait, just waiting for success here. Boom. Okay, there it is. And we didn't get any warnings. Okay, cool. Okay, so again, even inside your format strings, you need to pay attention to the data types that you're passing in, making sure that they don't, make sure that they match. Okay. Need to go back to the video to see how to get the memory debug view. Okay. So let's go ahead and fire up the local debugger real quick. Come on, hit the breakpoint. Windows. It's either in Windows. Yeah, there you go. Memory. Okay, so memory. So once you are inside, all right, here you go, Tyson. Once you're inside of a debugger instance, go to debug, Windows, memory. And what's kind of cool is you have 4 of them. Okay, so you can have 4 of them open at one time. The default right now that I have it is just memory window 1. Okay, kind of cool. Sweet. So one thing interesting to know is that, hey, no worries, Tyson. Yeah, all good, man, all good. One thing interesting to know about stir length. So stir length, yes, it's going to give you the length of the array, okay, or of the string, looking for that null byte, but it does not include the null byte in its length calculation. All it does is doing a little loop-de-loop, looking for that null byte, and it says, oh, all right, I think I found it. Then, we're good to go. So let me go ahead and change this breakpoint, see if I can show you something at the disassembly level. Not trying to turn this into an assembly class, but let's see if we can look at something just real quick. Okay, so it says call to stir length at that address. Go ahead and paste that address right there. Whoa, nuts. Okay, all this just looks like a giant jump table. Okay, and let me grab that one. Okay, and it looks like it's going through again. Okay, holy smokes. Okay, we're going to go all the way down, and I don't really want to drive all the way down. I was hoping to show you how it gets optimized. And where is it? Nope. Okay. All right. Well, I don't want to go too far down in the weeds of disassembly. Okay, let's come back to C. C is where we're comfortable at for right now, at this part of the series. Yep, could be overflowable. Absolutely. Okay, so yeah, so stir length again. Stir length does not take into account the null byte. Okay, and stir length, its job is just to go after the values of the array and see how many values are present for that array. Let me show you something else here. Okay, so there is another function called size of. Okay, so size of go ahead and do the parentheses. And if you hover over size of, come on. No, don't want to show me? Garbage. Like command.exe or something. Huh. I see what you're saying, TPZ. So before we get there to size of, okay, so let's go with what you were talking about there. Command, let's find out where that period is. 0, 1, 2, index 3 should be the period. Let's go ahead and say that's a null byte. And let's go ahead and do this. But before we go ahead and do the str length and we show what that is, we'll just go ahead and do this. Add another printf statement above that one and say the string is %s and new line. And the format operator, the format string value here is going to be CMD. Okay, so 2 printf statements. The modification here is we're coming in at the third item here and go ahead and reassign that one and say this is 0. Okay, and then we'll say printf, the string is that, and we'll say str length. And watch, let's see what happens. Let me change my breakpoint. Oh, don't steal my thunder there, TPZ. Don't steal my thunder, man. Okay, so change my breakpoint right there at command 3. So local debugger. Okay, we got a little bit of a warning there. And we'll go ahead and click that drop down so you can see everything in the array. And inside the memory window, I'm going to type in the name of that array and CMD. There we go. This is the address where that first byte is located. And we'll go ahead and let that go. Boom. So look at that. The period has been swapped out and updated to 0. You see that red now inside the memory window. And furthermore, on the right-hand side would be the ASCII equivalent of that. And it says CMD 0EXE. Okay, so let's go ahead and see how these printf statements work. It said the string is something. Okay, the string is command 0EXE. Okay, how about that? Is this truly a null byte, or is this an ASCII null? Okay, let's step over that one. Look, command 7, okay? Obviously, we didn't update the variable there. So when you're dealing with these variables that take in str length operations or any kind of length operations, make sure that you would do an update if you're trying to go ahead and say this should be a null byte instead of an ASCII 0. Okay, so a true null. Okay, so let's go ahead and change that. So how you change that, look at all these extra things here. Get rid of the double quotes and use the single quotes. Okay, and then we'll go ahead and redo our str length call. Okay, so I'm going to copy that. And right before this printf, we'll go ahead and call str length again, and we'll see what happens with this. So I'm going to save this one here. And then just going to pause a little bit just to make sure y'all can catch up. I think I was moving a little bit fast there. Okay, so again, coming into index 3, which is where the period is, and instead of doing a double quotes with our backslash 0, we're using single quotes. Okay, so getting the actual character here. And then a printf of the whole command. And update, we're going to call str length again, because we're expecting this to change. And I'll go ahead and print that out. Cool. So make sure you save it. And we're going to debug this locally. Wait and wait and wait. Come on now. Okay, so I'm going to drop down my command array down there inside of locals, and inside the memory window, I'm going to hit command. Cool. We'll see this thing change on the fly. Boom. Step over. It's been adjusted. Highlighted red. Look at that. Okay. So there it is. We have our true null byte instead of an ASCII 0. Okay. So this might change the behavior of str length by quite a bit. Let's go ahead and do a step over. And let's see what that printf said. The string is CMD. Interesting. Okay, let's go ahead and call str length. So step over that. Command length has now been updated. Say, whoa, 3. Okay, we have 3 values inside of this array. Go ahead and print that message out to standard out. And yep, cool. So str length command, after we have the update where we shoved a true null byte in there instead of an ASCII 0. Okay, so it says it's now 3. Okay, we'll go ahead and let that go. Cool. So you can see how you can jump in and access and assign, change any one of these values inside the index. Okay. Now, I would say make sure you know your index and the size of it before you come in and access something like this, right? Index 100 inside command, because that's going to get you some garbage values there. Never know what you're going to get for something like that. Okay, definitely don't want to go out of bounds. Okay, so the last thing I want to talk about here before we go to like Q&A type stuff is size of. All right, so size of is a way to get the size of data types or the type of a variable. So if I say size of, there we go, size of CMD. Okay, obviously we can't just have that on its own line. We're going to put this inside of a variable. Okay, we'll assign this to a variable. So it's of type size t. So size underscore t, command length size of, just to be different from command length str length. So I'll do our famous printf. And inside the printf statement, I'm just going to go ahead and say size of command. And we know it's a of type int 64. So we'll do % uppercase I 64 lowercase I. And pass in the name of the variable. Reading in some stack cookies with those types of shenanigans. Yeah. Yep, absolutely. You could. All right. So go ahead and save that one. And you can change your breakpoint if you would like to. What I'm going to go ahead and do is I'm going to change my breakpoint to where my size of is being called. Okay, go ahead and get rid of that window there. And once you have your breakpoint set up, go ahead and debug. Wait for the build process to go. Wait for us to hit the breakpoint. Come on, come on, come on. Cool. Here we are. We'll go ahead and step over that. It says 8. Size of 8. Okay, interesting. What's up with that? So we saw that str length shows 3, but size of shows something quite larger. Okay, so I'm going to go ahead and step over this and let that printf execute. There we go. We can see the two differences here. And let me get a little operator here. So we got str length showing 3. and size of showing 8. Okay, so please don't use size of to try to get the length of a string. Okay, it's not what it's there for. Okay, so size of will go through and look at the command variable and see what the type is. Okay, it's looking at the type and seeing all the bytes that are present in that type and show you the size of those bytes. Okay, so we have 8 bytes inside of that. And strlength, all its job is to go through and iterate over all the values inside of it. So looking at the value for this until it hits that null byte. So loop-de-loop-de-loop-de-loop-de until we find null, boom, break out of that loop. And then whatever that iteration number is, would be the length of that string. How many characters were iterated over until we hit the null byte? That's the value for strlength, okay? So you can't just go ahead and swap these around and just use them like crazy cowboy on the keyboard or whatever. There'll be a few more things you'd have to do to kind of make these equivalent. Yep, absolutely. You could do size of -1. You could also do strlength +1 if you want to take account for the null byte. Okay, if whatever operation you're about to do needs that null byte to be there and accounted for. Okay. All right, so we are about 10 minutes prior to the end of this ish. Well, no, 5 o'clock. We're good to keep going. Okay, so now we can keep going. We got what, half hour ish? Let's go ahead and talk about how in the world you can compare strings against one another. Okay, so let's go ahead and add a few more things. And for this one, let's call this K32. So char K32 with our brackets. And the value for this one is going to be kernel32.dll. Okay, so kernel32 from a Windows internals perspective is a Windows system DLL that is almost always loaded into every single user mode process. Almost always. And let's do another one. This one, I'm going to call this one KBase because the value here is going to be kernel base. .dll. Kernel base is another system DLL that will almost always be present in processes. And a lot of times, functions that might be present inside of kernel32 are simply forwarded into kernel base for implementation. Okay, so here we are at the next one. So char ntdll. All right, and then char ntdll, and this one's ntdll.dll. And I'm just going to hit return a few times. So question is, I think I missed something. Size of didn't care about the null byte that we put instead. No, it did not. No, it did not. So looking here at the code, right? So on my line 33, I have come in and swapped out that period that was there for that legit null byte. Okay, so the strlength function, it relies on that null byte. That's critical for strlength and other string-based operations. Okay, so size of is not a string-based operation. Okay, so strlength, it'll keep on going until it hits that null byte. Once it hits that null byte, boom, break out of the loop, done. Size of, though, size of doesn't care about those null bytes whatsoever. It's only going to be returning the size of a particular data type or the size of the type for that variable. Okay, so the variable we had was a char array for command. So hopefully that helped a little bit. Cool. Yeah. Awesome. Awesome. Glad to help. Okay, so here we are. We have 3 new arrays here. We got kernel32.dll, kernelbase.dll, and ntdll. Okay, so just as an aside, ntdll is another Windows system DLL. This is the only DLL that will be present in every single Windows process, because this is where the Windows system loader is implemented. So all of the logic, so when you double click an executable or whatever, and it gets mapped into memory, that mapping and all that stuff is happening by ntdll. Okay, other dependencies will be loaded by ntdll, and some of those will be kernel32 and kernel base. Yes, absolutely. Native API calls all go through ntdll. Okay, so we'll talk about later on in this series, as we get closer and closer to how 670 starts, we'll talk a little bit more about Windows internals, how it's structured, that type of stuff, the differences between native applications that only have ntdll present, like the session manager, and like Windows GUI applications or Windows console applications. Okay, some of the dependencies that are different between the two. Cool. So now we want to go ahead and do some comparison of strings. Okay, so to do that, there is a function out there called strcmp or strcompare, string compare. And what I can do is inside of a printf statement, we'll go ahead and make another printf statement here. Okay, I'm just going to keep that there for copy and paste reasons later as we use printf. Okay, so I want to have some kind of printf statement that will show you the result of a string comparison. Okay, so let's go ahead and do that. Let's say, is K32 equal to K base? Okay, so that's not K base. There we go. And we'll go ahead and return the value here, %i. This is where we'll go ahead and call strcompare. And strcompare needs 2 things. Okay, so you can see maybe on your side what it needs. It needs a constant char pointer to string 1, and then another constant char pointer to string 2. Okay, so string 1 for this instance is going to be kernel32, and then string 2 will be kbase, kbasa. Go ahead and save that one. Build it. Then you can just go ahead and run it. And it says -1. -1. Okay, so obviously those are not equal. Okay, so if you look up the documentation, it'll say that the strcompare function will go ahead and return null or return 0 if both strings are equal to each other. Okay, the -1 or 1 or what have you that could return otherwise is doing a comparison for a lexicographically comparison. Okay. We don't need to dive deep into weeds about all that. So the next one, let's go ahead and compare ntdll and kernel base. Okay, so is ntdll equal to kbase? Go ahead and do that one. So strcompare, kbase, K32. And the standard combo, save it, build it, run it. Okay, value of 1, okay, just to show you different outcome. And then to see the actual 0 that comes through here. Say, is ntdll equal to ntdll? %I, stir compare. NTDLL and NTDLL. Save, build, run. There you go, 0. Okay, so depending on the comparisons, you get -1 or you get a 1 to let you know, hey, they're definitely not equal. Okay, but what you're really going for is that return value of 0. Does stir compare look for null bytes for the end of strings? That's a good question. I don't know off the top of my head. I would imagine at some point in time, I'd have to go ahead and figure out the size of a string or the length of a string and look at it that way, possibly. I'd have to reverse that one out. It's been a long time since I reversed that one. Or you can just look up the docs on MSDN. It might tell you a little bit. Let's see, miss anything else inside of Discord? Looks like we're good to go. Okay, cool. Now, there is another thing, another function available to you, and it's called A to I, okay, or ASCII to integer. So if something's come along hitting you at the command line, say, hey, your prompt that you want to have for the user says, give me a number, and you give it the number of 23. A lot of times that's coming in as a char. Okay, so to actually be able to treat that as an integer, there are a few things that you go ahead and do that. So to make things easier, we'll say we got a printf statement, and we're going to say A to I, and the value of this is going to be, we're going to call it 23. And print, do %I. This is where we call the function A to I. And ATI needs a constant char star to a string, and the string is going to be 23. Okay, because we don't want to deal with the string 23. We want the actual integer of it. Okay, so save it, build it, run it. Hey, there you go. So it says the integer value for ASCII 23 is this. Okay, so just converting the ASCII value to an integer value. That way you can go ahead and do math operations against it or whatever you need to do for an int. How would I go about reversing that? Yes, absolutely. Bring it to disassembler, or what can be done is using WinDbg or a WinDbg or a WinBag, however you want to pronounce it. You can go ahead and do that as well there. But yes, some kind of disassembler. You have to see how that thing is working. Yeah. Okay. So let's go ahead and try to hit one more topic here. Staying with strings and staying with arrays here. So come on up to the top and make sure that you have your pound define array size. So pound define array size, and set it to whatever you want. I'm going with 3. Keep it short and sweet, and get rid of that breakpoint right there. Okay, so this new type of array is going to be of type pchar. All right, so pchar. If I do the semicolon right here, if you hit F12 on pchar. Reverse it out, TPC. Let me know how it works. Okay, so looking at pchar, it says it is of type char star. So char star. This is a pointer. This is a pointer to a char or of type char. Okay, so we're not going to be diving deep into pointers right now. This is going to be something we'll talk about in part 3 of the series, exactly what pointers are, addresses, stuff like that. And we'll get into looping as well in part 3. This is a lightweight introduction into that. Okay, so we have pchar. And this variable is going to be called the address of names. And the size of this is going to be our constant that we create up here called array size. Okay, so array size. Then we're going to go ahead and initialize this because that's what we do. That's a best practice. We initialize our variables as quickly as possible. Yeah, part 3, I'm hoping for at least 5 parts here. Might even get to 7. We'll see. Okay. So inside of this, we'll go ahead and initialize this to a couple of functions, function names like getProcAddress. Okay, so getProcAddress is a Win32 API that will go ahead and return to you the address of a procedure, okay, or the address of a function. There are many more that do that. Okay, there are some native APIs that do that, like loader-p getProcedureAddress or getProcedureAddress from caller, so on and so forth. Okay, so let's getProcAddress. Let's go ahead and say load library. Load library is another Win32 function, but in reality, load library is what's called a macro, and a macro can be expanded to the ASCII version. Okay, so it's load library A, or it could expand to what's called the wide character version or the Unicode version of this API. Okay, so later in the series, as we get closer to some Windows internals isms, I'll talk about the differences between ASCII and ANSI, or not ASCII and ANSI, but ASCII and WCHAR, YCHAR, or Unicode as what Windows is using here. Okay, so we got those 3 items. Okay, boom. getProcAddress, load library A, load library W. And what I want you to do is set a breakpoint at that line where you have your pchar address of names. And go ahead and run your debugger. Okay, it does this thing, blah, 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 cool. And then the address of names variable, they're in your local window. You can expand it, and it's been initialized, or right now, it has garbage data. It's a bunch of C's. And so let's go ahead and type in the name of the variable in the memory window. Address of names. Okay, a bunch of C's. We'll go ahead and step over that so we can see how that is filled out. Cool. Inside of our memory window here, we can see that we have some addresses. Okay, so these addresses are basically where the strings are being held in memory. So where in the world you can find the string for getProcAddress. Okay, it'd be that address right here, 7F, F7, A6, blah, blah, blah. You get the idea. Inside of your locals window, it'll go ahead and tell you what is at that address. All right. Thanks, TPZ. We'll catch you at the next one. So we can see that at index 0 is getProcAddress, index 1 is load library A, and index 2 is load library W. Okay, so just like any other array that we've created so far, you can go ahead and you can access any one of these by its index. Okay, so coming in here, if you want to grab address of names, index 0, this is what you would find. Index 1, index 2, so on and so forth. Okay, so again, because this is of type pchar, pointers to char types. That's why we see the values. That's why we see address values inside of this. Okay, you're pointing to a char type, which is just these strings here. These are all just function names that Windows uses and that people call to load DLLs into memory or to find an address of a certain procedure in memory. Okay. Now, before we go too deep in the weeds with pointers and things and stuff like that, you have to understand that everything in memory, once it gets mapped into memory, so the system loader, okay, brought to you by NTDLL, went ahead and it parsed the PE header of a PE image. It created all the pages of memory that need to, and the first thread was created, and that thread has a stack. Okay, so the thread has a default stack size of 1 megabyte. Of course, this can be changed, but typically the default size is 1 meg when that thread is created. Okay, so stacks don't grow, they don't shrink, they're of fixed size. Okay, so if somebody says, watch my stack grow, it's not a thing. It doesn't happen. Okay, it's a myth. Okay, so in any case, you have your stack. So right here, you have addresses. Okay, so you see there's an address right here. There's an address for this variable where it is in memory. Okay, so it doesn't matter if something is, we'll say, on the stack, or if we'll say that something is on the heap or in the heap. Okay, so doesn't matter where it is in memory, it will have an address for it. Okay, so in the realm of pointers, pointers are simply nothing but a placeholder, and the value of the pointer is an address. Okay, that's what that placeholder is. This address right here. What's at that address? Don't know yet. Don't know. We don't know right now because we haven't gone to the address. We haven't went out there and done something like a dereference. We haven't dereferenced whatever is there to actually get the value. Okay, so think of it like this. Like houses and addresses for a house. Okay, so in the US, we have addresses, we have a street address, we have a city, a state, a zip code, so on and so forth. Okay, so when you're just trying to send a letter through snail mail, okay, through the postal service, the letter on the front hand side on the envelope, you have an address. Okay, you have an address, and you stuff your message or whatever inside of that envelope. Okay, so you don't know exactly what's inside. You don't know exactly where that address is or anything like that. So that address by the Postal Service actually has to get dereferenced. Okay, you have to look at the zip code to see what region it's in, looking at the city, the state, so on and so forth, and then keep on going down another level to the actual street address where that residence is located. Okay, same thing can be applied in memory. We just have an address, like a street address where something is located. For this right here, this pchar, okay, it's a pointer to type char. And we see the very first item is this guy right here. To see it in a little Endian style, look at the locals window. And it's 7FF78600AF20. Okay, so if I go ahead and try to do this, so 0x7F F78600AF20. There it is. I went ahead and I manually dereferenced, if you will. I dereferenced that address or that pointer to say, what's there? What are you holding? And that is the get proc address string. Okay. Does that kind of make sense? A lightweight introduction into pointers, okay, or addresses in memory. Okay, that's so sole purpose in life is to just hold the address where something is located in memory. For this one right here that I just did was get proc address. There's a little saying I like to do when I teach SANS courses, and it's clear as Mississippi mud. And down in Mississippi, beaches and stuff can get pretty muddy down there, and it's very hard to see through that water. So clear as Mississippi mud. Cool. So some other Windows internals things right quick while I'm thinking about it. Address of names is something inside of the PE image when it comes time to talk about export address tables. Okay, we'll get there. We'll get there in future parts. In addition to future videos, are there other resources to dig into for Windows internals? Yeah, Pavel. Yes, Pavel Yosefovich, his books, grab them all. All right, so I think he has Windows 10 system programming or system programming for Windows 10, part 1 and part 2. Great books, absolutely great books. And then he's got kernel books too. All right, so don't do the kernel books first. Do the Windows 10 system programming books first. But also, if you look at Amazon, there's a book called Windows via C, C++. I forget who wrote it. I think there's 2 authors. Windows via C, C++. Okay, that one is a great book to have in addition to Pavel's books. Okay, the Windows via C++ one is a massive book. Okay, now obviously it's specific to C++, so all that code is going to look different and all that stuff to what we're doing here for this series. But in any case, it's a great way to understand some Windows internals from a programming perspective. $272. Whoa. I did not pay that. That's insane. Yes, Jeffrey Richter. That's who it is. That's an interesting error message or warning. Was that a warning, Tyson, that you got? A warning or an error? Because I definitely did not get that on my end. Did you, Tyson, did you create your array exactly like mine here? pchar, address and names, the array size, which is basically just a pound define 3. And then curly braces on either side here. And then the functions are the strings inside. Because you really shouldn't be getting that. No, it's all good, man. It's all good. Okay, so let me talk about one more thing real quick. Okay, so talk about pointers to things and stuff. Okay, there's something called a p-void. So p-void. So if you go ahead and F12 that. F12, brought to you by the WinNT header file, is the type void star or void splat or void asterisk, whatever you want to call it. I just call it a splat, right? Fun to say. Okay, so that's a p-void. It's a void splat. Okay, and the p-void is kind of nice. It's a nice type to deal with because it's easy to cast to other data types that you might need on the fly. So for example, if you're allocating a chunk of memory in a heap using something like heap alloc or malloc, okay, it returns to you of type p-void. And it's very easy to go ahead and change that to other types like pchar or puchar or pint or however you're going to be using that chunk of memory. Can I see how you defined array size? Yeah. Yeah, so at the top, I did a pound define array size 3. Okay, so that's my constant. And I just use that inside of the brackets there and just initialize each member off the bat. Then you should be good after you do that. Yeah, hopefully you're good. Okay. Let's go ahead and type in this p void real quick. Okay, so p void, and I'm going to call this one the address of functions. And this is going to be array size as well. So array size. Oops. Okay, so address of functions with array size, and then inside of this, I want to actually have the address of the functions, or in this instance, these right here, these strings. Okay, so there's an operator, the and, the ampersand. Okay, so we're not doing a bitwise and, but in C, the ampersand will say, I want you to get me the address of a certain variable. So go out there into memory and bring back to me the address of where this thing is located. So I'm going to say address of names, index 0. And I'm going to do this for everything else. Index 1 and index 2. Save that. Now you're getting a constant char cannot be used to initialize type pchar. Interesting. Okay. That's okay. All right, cool. Yep. Okay, so once you have this array created of type p void, address of functions, array size is our size, and we say the address of names index 0, address of names index 1, address of names index 2. I want you to go ahead and fire up your local debugger. And we'll hit that breakpoint for address of names. Okay, cool. So sticking with our debug build here. And breakpoints there, diagnostic tools are good to go. And cool, so everything's loaded. Here we are. Okay, would CPP file ending cause that? Yep. Yes, exactly. Sorry, I probably should have mentioned that. So this whole series, this whole workshop series is not C++, it's just C. All right, so all your source code files should have the .c extension instead of .cpp. Cool. Hopefully that takes care of that one. Awesome. All right, so at this point in time, in memory, these have not been initialized. We have garbage data in it, okay? Just a bunch of C's, hex C's to be precise. So let's step over that. We initialize address and names. Boom, that's all red. Okay, cool. And we'll go ahead and step over the initialization for address of functions. Okay, so address of functions, if you look at the locals window, I'll go ahead and expand that out, and you can see all the indexes or all the index items inside of that array. Okay, so what we could try to do is I want to try and copy the value, paste it in the address window. Okay, and I want to do some validation. I am trying to see if this really is the address where getProc address is stored in memory. So inside of my memory window, looking at index 0, it gives me the address of the ending in FC98. Now look at that, and that has the value of 7F, F7, FB, F2, AF20. Now, what I can do is I can look at this and validate this a few different ways. I can go ahead and manually put that address here inside this memory window, or just come over to my address of names array and look at the first item. And the address it shows here ends in AF20. And that indeed is a 100% match. Okay, so the code is actually working as intended. Okay, sweet. So we see how we can use this address of operator, or the AND operator, to go ahead and get the no kidding address where this particular index is located in memory. Okay, so that kind of makes sense, right? Basically just addresses in memory. Okay, they can hold different things, they can hold different types, they can hold strings, they can hold integers, so on and so forth. Okay, they're just a placeholder, right? Just pointing to something in memory. That's it. That's all pointers and addresses are. All right, I'm just gonna hit continue, let that thing run and terminate, and I'll go ahead and close that window. All right, so we are officially almost out of time here, and we have about 5 minutes remaining. So I want to open up to some Q&A. Okay, so Q&A about anything we just covered for this portion of the series, or anything SANS related. Okay, so for those that didn't take part 1, might not know who I am. I am the author and instructor for Security 670. Which is a red teaming class on how to create implants for Windows using C, C++. And this is a prerequisite series for that course. Part 3 will be coming next month. Okay, so I'm wanting to do each part every month. Okay, so 1 part per month. All right, so August, look at August. I haven't picked a date yet for August. But we'll do one August, do one September, October, November, or whatever, until I feel that we're good enough as a prereq for 670. Oh, cool. Yeah, man. Love to have you in the course. Absolutely love to have you in the course. Right. Looks like I missed some messages in. Yeah. Okay, cool. Oh, thanks for that comment. Yeah, thank you so much. One of the best courses I've ever taken. Awesome, man. Thank you so much for that. Oh, okay. So the best way to communicate with me would be on Discord, would be my most preferred method of communication. Okay, so 670 has a channel inside of Discord, so you can also just hit me up directly inside of Discord. Also out there on Twitterverse. So if you want to hit me up on Twitter, you can find me there. However, I think Discord is the easiest. Yeah, you're welcome. Cool. So if nobody else has any other questions or comments about what we covered today, so part three will be continuing on with pointers. We'll be creating pointers, pointer variables, more pointer arrays, looping over them, how to dereference pointers and stuff like that. So we'll also get into how to create functions as well. Okay, so be looking for part 3 to be announced for some date in August. All right, well, thank you all so much for joining part 2 of this series of an introduction to C for Windows developers. Thank you so much. Again, y'all have a great evening or afternoon or morning, wherever you're coming from. See you next time.